I'm going to be talking about carbon, the most fascinating element there is, right? Yes. And as your eyes glaze over, that's one of the things that I'm really, one of my objectives was finding relevant questions for my students. You know, I can find, when we're talking about carbon, I teach 5th and 6th grade science. In 5th grade, we talked about physical science, and talked about elements of carbon, trying to get them ready for earth science. So I can find really cool fossils that show the carbon, imprints left of ancient plants, or I can find a real piece of carbon, a piece of coal, try to get them excited. Or when I have to, I'll take a piece of coal and throw it at them.
I caught that on camera.
So even then, right after it's thrown and they realize it's not real and no one got hurt, they fall back asleep. So I'm constantly looking for that relevant question and trying to help them see how important carbon really is. Without carbon is one of the basic elements of life. If we didn't have carbon, those bonds of carbon, we don't have energy. And so getting them realizing how relevant it is, how important it is, and then finding a local question, something they can investigate themselves so it makes sense. Why in the world am I studying the carbon cycle? We have to get into that carbon cycle, and everybody's familiar with it. It's something that you can't really connect to. We know that carbon dioxide is released into the atmosphere. We know it's stored in places, stored in rocks, but what's the issue? And most everybody has seen this graph. It's one of those famous graphs when we talk about climate change, how the levels of carbon dioxide are constantly rising. And we're trying to help them make a connection. Well, still, all of this is just flying over their heads. They don't really care. Why is it important? Why do we have to learn about this other than my teachers making them do it? Well, what I realized is that trying to find something locally that we can sample, right? What I discovered was, why am I looking at carbon in the soil? 10 to 40 trillion kilograms of carbon have been released to the atmosphere from the soil in the past 2 centuries. And if we look, this is over several thousand years of carbon dioxide in the atmosphere. Right? Since the 1800s, you can see that dramatic increase. And a lot of this is coming from carbon being released from the soil. It's one of the largest carbon inputs to the atmosphere. I had no idea. Right? When we think about carbon being released in the atmosphere, we're thinking about CO2 from fossil fuels being burned. Well, it's deforestation. There's a lot of it. As we have to cut down forests to make farm fields to grow more food, all that forest, all that carbon is being released into the atmosphere. And so as we grow and get more cities and things expand, is the carbon being released from the soil that is a huge impact. So what I was trying to realize is that that large part of change in CO2 is taking forest agriculture. Well, then shouldn't it be if we put it back into forest? Will we be sequestering more carbon? So can we make a big impact on climate change? Can we make a big impact in storing more carbon to help restore that balance by taking the ag land and putting it back into forest? And will that happen? So that was my question. Is the amount of carbon stored in the soil related to the age of restoration? And I was looking specifically in plots of certain sizes, 5 to 20 hectares, in the Cypress Creek National Wildlife Refuge. One reason I chose those is because there was a student, Craig Russell McLean, who looked at species assemblage, did species change in those restoration sites, but he also took carbon data. So I had some older carbon data to work with. And so I went to his sites, and that's where the Cypress Creek National Wildlife Refuge came into play. My hypothesis is that the amount of carbon stored in the soil will increase with that age of restoration. Just like we lose the carbon as we cut down the forest, so as we build the forest, should that increase. I would expect it to be that way. I have the range of sites that I went to. When he did it, it was a 1-year-old site. It was in 2008. I'm doing it in 2012, so it's a 5-year-old site for my youngest, up through 6 to 11, 12 to 22, and then we had also mature sites that we looked at. So we had a full range of sites, and as to choose these sites, and my methods, I sampled the soil, prepared the soil, and then analyzed the soil. In choosing the sites, he had criteria. They had to be sites that were immediately restored after they stopped being farmed. They had to be within the Cypress Creek National Wildlife Refuge, and they had to be those certain sites. so that, we were looking at consistent sizes of plots. When I plotted, I went to his 20 sites and I plotted them out so I knew where I was going. And I was looking at them the first time, I was like, wow, looking at this map, I was like, this looks like private land. This isn't Cypress Creek National Wildlife Refuge. What am I doing? How am I going to get permission to be on all these sites? Well, I plotted it on a, I'm going to turn this off just for a second. I plotted it on another, where'd it go? I plotted it on another map, and these tan areas are the Cypress Creek National Wildlife Refuge. And you can see all those dots where all my sites are. So, I went, oh, thank goodness. They really are. They really are in the Cypress Creek National Wildlife Refuge. My sampling tools, pretty simple. I had a GPS unit that I took with me. I could get within 20 feet of his exact site, so I knew exactly where I was going, centimeter samples. And then I had to take them back to the lab and sample them. So I started early because I knew I was going to have to spend a lot of lab time. So I did all my sampling before this 2 weeks started. Got them into the lab, had my 20 samples, took them, I put them through a 4mm sieve, put them in a bag, and then they are sitting happily in the oven. Aren't those pretty samples? Very, very happy samples in the oven. They needed to dry a couple days because the procedure I'm going to use to analyze includes weighing the sample, firing them in a furnace to remove the carbon and weigh them again. So I wanted to make sure the water was out so that I was only going to be measuring the amount of carbon that was being lost. So I needed to dry them for a couple days, and then I needed access to the furnace. Now this is where I've run into a little bit of problem. I'm working with Dr. Battaglia and one of her grad students, Shashir Powell, and he took me to the two furnaces they have. Well, they have two furnaces, shouldn't be a problem. The first one would turn on, but we couldn't adjust the temperature. Second one, we could adjust the temperature, but it wouldn't turn on. So I've been in search of an oven. Now I do know Dr. Kluback in plant soil science. He taught me soils back in 1984, so I've known him for quite a while. And so after with Shashir, we ran into that trouble. I walked over to his office and said, Dr. Kluback, I needed a furnace. He said, I said, no problem, you can use one of my furnaces. He took me to show me the furnace and said, but I'm going to be gone this week. Can you come back next week? So I actually going to process my samples next week. Now that doesn't mean that the presentation stops there. I do have Craig's data, right? So this is all of his beautiful data. Isn't that nice? This is all my data. But it's going to be nice that I will completely understand his data. I've had practice working with his data. I'll be able to compare my data to his, and so I'll get some good comparisons. If we look at his carbon data from the 20 sites, and they are arranged in age of restoration, so his age was from 1 year down to the mature sites. Just looking at these numbers, we see a range from 1 to 3%. The soil surface layers typically contain around 5% carbon. So even just looking, just sitting with data, just staring at this, you can see, well, maybe there's a little difference, but even in some of the mature sites, we're getting around 1%. So I did a little analysis. And because it was between 1 and 5%, my y-axis 5%, and then across the years, maybe there's a little bit of an increase with the age, but this is one of the mature sites. So does this line really, is it accurate? It has an R value of 0.5, it ranges from a -1 to a +1, so maybe there's something. So I thought, well, I played around with the data a little more. And this time I expanded my Y, because I thought about pulling it all the way out to 100%, but then things got a little too crunched. So I took it to 25%. And actually this kind of curve, I thought, wow, that's almost what I would expect. As things would start to grow, it would be absorbing a lot of carbon. It wouldn't be putting it back into the soil yet. Then as, it would start, after those things got a little older, the plant material would be released in the carbon, or released into the soil, carbon would start to accumulate, but then as things got bigger, if you remember those pictures, we get trees, they might drop off a little, but increase as they got a little older, and then as things grew again, you might get another increase. Is it possible, or am I just seeing things in data just because that's what I want to see? So I thought, well, what if I went back to more of a linear regression? And again, I'm looking at it thinking, what I really am seeing, it's almost a straight line. Is there anything here? That was one reason Dr. Tagley was interested in having me do a year, 4 years later. We'll get twice as many data points, and we'll extend it into this blank range. So we might start to see something. Hesitant to make any positive conclusions. I still am saying there's no real clear relationships between the age of restoration and the amount of carbon stored. But maybe. And if I get my data. So I'm hoping it's going to be fun next week, and I expect everyone back here about this time next Friday, and we'll see how it turns out. Now, my further studies, as you know, we're thinking about the flooding differences. In the data, you can say within centimeters, it can make a difference. Carbon can get moved through the soil from water. So if there's a lot of water, carbon might be moved out, or other carbon might be brought in. So the water is an issue. So in the sites I went to, like everybody else found, there was only one site that I had to walk through any water to get to the site. Now, is there more carbon there now because there isn't water? I don't know. So do I need to look at flooding? Maybe the types of plants make a difference. Maybe how many plants are there? Maybe the species of plants make a difference. And that was my original study I had hoped in doing, looking at diversity, plant diversity, and carbon storage. But it took Craig several months of setting up 10-meter quadrants, measuring plants, counting plants, and identifying plants. I really would love to do that, but it would probably take me 6 months to do that. I don't have the time at the moment. Can I do something like that with my students? Maybe not in the cache, because some of these sites I went to, I wouldn't be able to take 75 students. Well, maybe if I pushed the 75 students through in front of me, and I could walk through like this, that would work out great. But so, what am I thinking of doing? Can we look at agriculture practices? Are there landscaping practices that can sequester carbon? Remember that plot? Even some of the grasslands store a lot of carbon. So what if we sent up we have quite a few acres around the school. What if we measured? We have a restored prairie. What if we measured some of those places and saw? Is there differences in carbon? Could we then start encouraging people in landscaping practices? Maybe the areas, I don't want to get rid of all the lawn, because sometimes you need the lawn areas for use outside your house. But what if we started encouraging people, maybe if you could part that you're not using, you can help store carbon by not mowing parts of your lawn. And maybe they can help develop uses, relevant uses, that they can make those personal actions. So finding a way, if you remember back in the beginning, talking about how can I make this a relevant study for them. Now that I have samples of, a real scientific study, we can then investigate locally around the school, even in their own yards, to help them make that connection to carbon and the carbon cycle and see that importance. That's where I'm going. I just need to thank Dr. Tagley, Shashir Patel, Craig. If I could find him, I would buy him dinner, because I wouldn't have this presentation without him. And Dr. Brian Kluback is going to be helping the process with samples. So that's what I have.